And we're looking at numbers 1 to 6, where they ask us to graph the derivative of the function whose slope of the function shown below. So let's look at the first one. Here we have a straight line. It's horizontal, and the slope on the line is constant. So the slope of a horizontal line is always 0. So in red, I'm going to graph right now. We have a line where the entire slope is 0. Because when we graph slopes, it's like we're saying this is the x-axis and now this is the slope axis. So here would have a value of slope of 0. Alright, so let's look at number 2. Number 2 has two different line segments. This line segment is at a 30-degree angle and this one's at a 45-degree angle. Okay, so they're both lines, which means they both have constant slopes. And using right triangles, we can find out that if this side was 1, this side would be 1/2, and this side would be root 3 divided by 2. So if we use a calculator, we can say that the slope of this part is rise, or 1/2, divided by root 3 over 2, which basically becomes, using our calculator, 0.577. Now we know the slope is negative because it's going down from left to right. So if this was -1, our slope from here to here, I'm going to put a closed dot on the end all the way, and I'm going to put an open circle. Oop, you can't see that that is open. Let me show you that this is in fact an open circle at 0. Alright, finding the slope of this. If this was 1, this would be root 2 over 2. This side would be root 2 over 2. So our slope for this side would be root 2 over 2 over itself, which is just 1. So since it's going down from left to right, the slope is -1. We're going to put an open circle at -1, and it's all -1 from there on. Closed circle at the end. Alright, number 3 is less specific because there are no actual values here. The only thing that I want you to mark, first of all, that is very specific, is where the slope will be 0. And the slope will be 0 anytime our function goes from having a negative slope to having a positive slope. So that's going to occur right here at -1. It's going to occur right here at 0. And it's going to occur right here at +1. This had positive slope to negative, negative to positive. And once again, this is like the slope axis now, right? So this is a slope value of 0 at these x locations. Alright, so over here to the left of -1, all of these points have negative slopes. Here is the negative slope region. They are steep up here, and they get less steep as we go along. So they are bigger numbers, and they get less steep, less smaller numbers as we get closer and closer to that 0. In between -1 and 0, we have all positive slopes. They start out small, they get bigger, and then magically right around the middle here, they change and they start getting smaller again. From 0 to 1, all of our slopes are negative. They start out small, they get bigger, and right around the middle, they start getting smaller again, getting back for that 0 slope. From 1 onwards, we see positive slopes. Alright, let's look at 4. We have a 0 slope and a 0 slope. The slope is 0 everywhere. Right here, we have a jump discontinuity. So actually right here, the slope does not exist. There is no tangent line. So we're going to put a 0, we're going to put an open circle right here at 0. And to the right and the left, we're going to show that that slope is 0. All right, looking at number 5. We have a function whose slope is positive everywhere. However, at the ends of the function, it looks as though the slope is approaching 0. So what happens here is, and if there were arrows, it would be a little bit easier for us to tell. I'm going to think of this as though there are arrows on the ends, meaning it keeps going in that direction. Adding that to it, I'm going to imagine that the slope approaches 0 as the function keeps going. So over here, the slope is approaching 0. It's all positive, that's why I'm above the x-axis. As I get closer and closer and closer here, they get steeper and steeper and steeper. Until at this point in time, around x equals 0, they're pretty much vertical, which means like an infinite slope. They're so steep. Or an undefined slope. Starting right around here, we have those really steep, those infinitely steep slopes. So that's going to start up here, but as we end up, we are decreasing our slope value until it is pretty much 0. So this is our slope function here. All right, a similar thing happens here. The only difference between number 5 and number 6 is that we have positive slopes over here, but negative slopes over here. So let's talk, same thing is going to occur on the right-hand side. The function is increasing. As we get out to the other side, out here to the left, it's almost 0 slope. But as we get in closer and closer and closer, it gets steeper and steeper and steeper until it's like infinity. Starting out on the right-hand side of 0, these slopes are all negative, which means below the x-axis, right? Negative slopes down here. They start out at like negative infinity, so steep, and yet they get closer and closer and closer to 0. All right. Moving on. We did number 7.